came to Ferraz de Vasconcelos, here in Greater Sao Paulo, to the Nufix factory, to show you how a screw is made. Borov. You might have imagined that making a screw is simple. Just take a piece of wire, cut it, and thread it. But hold on. Grab your popcorn, sit on the couch, and watch this video. Because it's way cooler than you think. It starts with the raw material before it becomes a screw. It's a huge coil of wire that can be up to 10 kilometers long and weigh nearly 2 tons, depending on the type being made. The wire goes through a chemical bath in acid to remove impurities, then gets rinsed with water and goes into another bath. This time it's a zinc phosphate bath, which protects the wire and acts as a lubricant. In addition, the wire also receives another layer of lubricant, the drawing soap, which prevents friction and overheating. This machine reduces the wire's thickness. It leaves the coil and gets pulled through the middle. It has to pass through a part that looks like a funnel, which is very narrow, narrower than the wire itself, and it comes out thinner on the other side. But this happens multiple times. So there are several spools here pulling the wire, making it go through one more little funnel, then another funnel, then another, until in the end, it comes out much thinner. It's like chewing gum. You keep stretching the gum. Imagine how hot this thing gets. For context, for every kilometer that goes in, 7 come out on the other side. It's pretty wild to think you can do this with steel, right? Depending on the product, the wire goes through a tempering furnace, which makes it more flexible and prevents cracking. You can't even get close, it's way too hot. It stays in there for 8 hours and then cools down for 6 more. Now it's time for the head forming stage. It's done with brute force. This is a cold forming press. First, it cuts the wire to the correct length, then delivers a first blow that gives the screw a rough shape. The third blow shapes the head, and the fourth one forms the edges of the head. It becomes hexagonal. Let's try to show it in slow motion here, though it's not easy to see. I managed to get the part that's inside the machine to create the hexagonal head. Look, the machine strikes the screw while the head is still round. That blow cuts off a piece of metal that forms this leftover bit here, kind of like the inverse of the head. This is where it starts looking like a real screw at the threading press. It arrives and passes through a vibratory bowl that lines everything up neatly inside. There are 2 pieces that scrape around the screw, which still has no threads, and the thread gets formed through pure pressure. The process also uses a lot of oil and heats up the screw. That's where the smoke you're seeing comes from. We got our hands on the key component of this whole process. Take a close look. The screw arrives smooth, and it's these grooves that press and imprint the thread. See this slightly raised spot down here? It's used to cut the tip of the screw, which is why, if you look closely, the tip is a bit darker from getting so hot. Depending on the screw type, this part looks very different. This one is for machine screws, the kind you pair with a nut. The grooves are much finer. Here they also make nuts, but the process is a bit different. The first thing this machine does is cut the wire to the nut's exact height. Then, with each strike, it hits against a mold, and that little ring gradually takes on a hexagonal shape. Next, it's time to punch the hole in the middle. That's also done with impact. A punch strikes repeatedly, displacing the metal until the nut comes out perforated, just like you're seeing here. But it still doesn't have threads. If you thought everything seemed a bit rough so far, picture an even more intense process now. The nut gets squeezed against this part here, called a tap. It spins around, and this reverse threaded section is what forms the internal thread. The process is so aggressive. I'll put a microphone right here so you can hear it. The amount of oil used is absolutely insane. hold on, the screw's story isn't over yet. Both the screw and the nut go through several processes to ensure they'll hold up well when used. It starts with a high-pressure water wash to remove dirt. Then it's dried in a centrifuge and goes into a furnace at 900 degrees for 50 minutes. But it's not a regular furnace, it's one with a controlled atmosphere inside. There's a carbon-rich gas, and the heat causes carbon to bond to the metal's surface, making it harder. This boosts the screw's strength. Right out of the furnace, it gets a bath of oil that cools it rapidly, making it very tough, and there's still another bath after that. Think of a really clean animal. This one removes the oil from the previous step, but there's still another acid bath to eliminate any trace of rust or impurities. All this is to prep it for the final step, galvanization. There, the screw gets dipped in a zinc solution that adheres via an electric current. This creates a protective layer that prevents corrosion, no rusting allowed. And depending on the solution used, you get silver, gold, or black screws. This is so cool. There's a zinc bar inside, and with electricity, the zinc leaves the bar and deposits onto the screw. After a while, it ends up looking like this. Now it's time to package. And as with everything here, it's a bit more complex than it seems. This machine is a weighing dispenser. Screws drop into several different containers. As soon as any of them reaches the correct weight, it releases downward. Meanwhile, another machine assembles the boxes. At some point, the two meet and go through one final weight check. And only then is the box sealed and ready to go to inventory. Check out this neat solution here. When the screw is very large, you can't just toss it randomly into the box. It has to be neatly aligned. That's done with two magnetic blocks. The screw falls between them and comes out perfectly calmed, ready to grab. From the outside, it's hard to imagine the insane variety of screws that exist. Right here on my table, I've got 8 different head types. Let's see if you know them all. Flat, truss, pan, flange, oval, countersunk, round. But hey, if you didn't know them all, I think that deserves a thumbs up, right? And if we consider thread types, lengths, plus the fact they also make nails, nuts, and rivets here, this factory alone produces over 6,500 different items. Monthly, they make more than 400 million pieces. If we line them all up, they'd circle the globe twice over. If you watch this, you probably enjoy big factories that handle heavy-duty stuff, huh? Then, check out our Barav episode, where we filmed at an aluminum plant, showing how aluminum is made from bauxite all the way to aluminum foil.